People, suppose we consider these two vectors. And let's say that this vector here is 100, is a force of 100 newtons. And this one is a force of 80 newtons. The angle between this vector, the 100 newton, and the horizontal is 75 degrees, while the angle between the 80 newtons and the horizontal is 15 degrees, right? Or say 45 degrees. 45 degrees for this one. Say 45 degrees for this one. Now, the thing is, we want the horizontal and the vertical components of each of these vectors, right? So, what we can do is do a little calculation. And we calculate and say this is the opposite to 15, right? Now, being that this side is the opposite to 15, and we want the adjacent, we say tan of 15 would be the opposite over the adjacent. Oh, no, wrong thing I did. We have the hypotenuse, so we use sine. Sine 15 equal opposite over the hypotenuse of 80. So the opposite would be what? It would be 80 times sine 15. You see that? So in that case, we're looking at 80 sine 15. We want our calculator. So, calculator. We have 80 times the sine of 15 degrees. And make sure it's in degree, alright? Angle in degree equal. We have 20.7. Call it 20.7. Alright. So this is 20.7. What about the adjacent? This adjacent, we use cosine. Cos 15 is the adjacent over hypotenuse 80. That adjacent we're talking about is this length here, right? So the adjacent that we want is 80 cos 15. So in that case, we look at our calculator and find 80 times cos 15. So we say 80 cos 15 degrees equal 77.27. So 77.27. So up here is 77.27. Now notice that if you consider the horizontal and vertical component, the horizontal is equal to, and it's 80, the length cos of the angle 15, and the vertical component that's over here, that's the vertical component, equal 80 sine 15, right? Remember, if we have theta and we call this I and this J, what we have is the vector, the length of the vector is equal to I, it's V, let me erase this part. So it's going to be I plus J, right? So it's going to be V cos theta by I in the direction of I plus, and then V magnitude sine theta in the direction of J. You remember that? All right. So we have the horizontal and vertical component of this vector. What about the top one, the blue vector at the top? Let's see what's going to happen. Let's do the calculation for that. We have this length is the opposite. So sine 45 is the opposite over the hypotenuse 100. So to find this is equal to, this length is equal to 100 sine 45. What do you get for it? Let us see. Calculator again. So we get 100 sine 45 equal 70.71. all right, 70.71. and then this length, the adjacent going across here, right, is going to be, well, you know that cos 45 is adjacent over hypotenuse 100. So this adjacent, remember the adjacent is going across here, but we don't have space to write all of this in there, is 100 cos 45 equal what? Calculator again. So 100 times the cosine of 45 equal 70.71. Well, as expected, you know that would be the angle. All right. So what you have there is 70.71. Now the thing is, we have a situation where we have resolved these vectors into their horizontal and vertical components, right? One of the vectors, the blue vector, if you draw it like this, you're looking at, well, the blue vector would have a similar height and length, right? So let me kind of make it look similar. 70.71 J and 70.71 I. Same going across and up. And then the red vector now, you go this way and down. And we are looking at 77.27 and 20.7. Now, you see that. What we're going to do here is imagine that we add these two vectors now. Suppose we consider using the parallelogram law. We take this vector, put here, and this vector we put here to form the parallelogram. You see that? Let's get rid of some of the working we did. Try to remember it's 15 and 45 degrees. So we form the parallelogram. This was 15 and 45. 15 and 45 give what? 60 degrees. So all of this would be 60. This would be 60. We want to find the angle here. What would be that angle? Well, We know everything add up to 360. 60 and 60, 120. So if we subtract them, we get 240. And each angle here would be 240 over 2 equal 120. 120 degrees here, 120 degrees up here. Must remember your trigonometry, right? So what we have basically is this. We have this vector, we have this vector, we want this vector, and we have this angle at 120 degrees. We know that the red vector is 80 and the blue vector is, what was it again, 100? 100. So we can use cosine rule, right? So if we consider this as a squared equal 80 squared plus 100 squared minus 2 by 80 by 100 cos 120. So we can find the magnitude of a, right? So in this case, we use our calculator again. Now, all right, we have done some hard work and coming on to more hard work. So let us take a break and continue in the next video.